Okay, so very quickly, I'm going to do number 7 overall, but let's just quickly describe, in case you've done this, the end behavior. So we can end the beginning. Well, let's say the end behavior and beginning behavior. If you look at this one, the beginning behavior as x approaches negative infinity, which is, by the way, how all beginning behaviors are. It's x approaches negative infinity. Y is on the top, isn't it? What quadrant is this? This is quadrant 2. In quadrant 2, x's are negative and y's are positive. Therefore, we can say, since the graph is here, as x approaches negative infinity, so that's that part, y approaches positive infinity. That's that part. You can see the quadrant use is very useful. What's the end behavior? Well, what happens in quadrant 4? X's are positive and y's are negative, and we can see the graph is down in that quadrant. So that means as x approaches positive infinity, that's that part, y approaches negative infinity. That's that part. Bonus. What kind of graph is this? It has 2 turning points and 3. What's the minimum that this graph can be? And 3 x-intercepts. Therefore, it's a cubic. What are the x-intercepts? X minus x plus 2. That's the minus 2, 1. X minus 1. That's the 1 here. And x minus 3. And for extra bonus, we're going to determine the equation of this graph the same way we're going to do number 7. Okay, so after you do all of these, see if you can do 7 for this one and 7 for that one. Okay. And maybe watch one first to see as an example and then try to do the second one. State the possible degree of each function, the sign of the leading coefficient, and the number. This has clearly got 2 turning points and 3 x-intercepts. Therefore, it's a cubic. Since it all starts in quadrant 3 and ends in quadrant 1, it has a positive leading coefficient. This is clearly a comes from here and ends here, so it's going to have an even power. There's 1, 2, 3, 4 x-intercepts and 3 turning points. So this is a 4th degree polynomial. And since it does start in the normal and ends in the normal area, it has a positive leading coefficient. Write the equations of 3 cubic functions that have a given 0 belonging to the same family of functions. Let's just make that write 3 functions that have this given zeros. So just write one function of a cubic function. We'll just do that because what they're looking for families is they have the same. I'll give you an idea of this, what they want. So you got x plus 3 for the minus 3 point, x minus 6 for the 6 point, and x minus 4 for the plus 4 point. And all they want for 3 different functions is one has a 6 in front, let's say, one has a negative 3 in front, and one has a whatever, a plus 11 in front. So because they have the same root, they're the same family, and then this number makes them different graphs. That's all they want. See if you can do it for the next one. Sketch this graph. So start by saying, what kind of graph would this expand to be? Figure out its beginning and end behavior, mark it on the graph. Then figure out how that graph has to cross the x-intercept, and figure out which one of these points is the most furthest left because it would have to cross through that point first. And then see when it goes to the next point and the next point and figure what kind of graph it is. And then the end behaviors depend on what kind of graph that you think that is. Okay, on to number 7 and indirectly number 2. So we're going to keep them both. Ready? It's a lot simpler than you think. So we would start with this. We would say, you know what? Y is equal to A. There's going to be some number up here. And then the intercept points. Okay? So let's see. We have an x, zeros at plus 1 and minus 1. So I'd like you to stop the video and see if you can do the rest. Okay? And then the last one, the next two, we have one at minus 2. And that's it. So that would be, I got 3 of them. That plus minus 1 means there's an x plus 1 and x minus 1. I've got 3 of them. If this were to expand, it would be a cubic. So let's draw a graph of where the cubic would go, and let's figure out those points. So x minus 2 is 2 comma 0 over here. X minus 1 is 1 comma 0 here. And x plus 1 is 1 comma 0 here. So if we start here, it's going to got to go up here and go down here and go up here. But if it has a negative leading coefficient, it's going to go down here, it's got to go up here, and it's got to go down here. It all depends if A is positive or negative. And the secret is the y-intercept. Okay, they tell me the y-intercept is well down here. If I were to start in this area and go through this, I have to go through the x-axis to get to the other side. There's no x-axis in between. Well, the y-intercept is over there. So it can't possibly be doing that. It must start up here, go through this first one, go through this y-intercept, which is 0 comma minus 6. Come up through this one, turn around, come down, and end here. It's got to. It's got to cross the x-intercepts because I can see it's a cubic. It can only cross 3 times. It either starts here and ends here, or starts here and ends here. And since we got to cross through that y-intercept, it's clear it does that. That tells me right away A is negative. But there's a better way of doing that. They tell me these 3 points here on the x-axis. That tells me those 3 factors here. Now it's figuring out A, the only missing thing. Well, they gave me one other point, and this is the important part. This other point cannot be an x-intercept. It's got to be an independent point. And I can see they tell me it's 0 minus 6. That means when y is minus 6, x is 0. That means I can take my little equation here and I can rewrite it where I see y minus 6. I don't know A, but I know when x is 0, y is minus 6. So everywhere I see is x, I'm going to put in a 0. And then I'm going to look at each bracket and solve it. Well, 0 plus 1 is plus 1. 0 minus 1 is minus 1. And 0 minus 2 is minus 2. Notice that this instantly tells me, okay, well, I'll just keep going. 1 times minus 1 is minus 1. Times minus 2 is plus 2. So that means this comes out to plus 2. So that means 2a is equal to minus 6. I have to figure out a, so I'm going to divide both sides by 2. The 2's cancel. Minus 6 divided by 2 is minus 3. Which means I can now, where I see a, just rewrite the general equation and put minus 3 there. You can test this out in Desmos and see if indeed this graph passes through 0 minus 6 and meets all these x-intercepts. It's also going to pass through 0 comma minus 6. And I'm pretty sure it will, and that's why Desmos is very useful. You could also graph it yourself if you want. And you could take other values of x. For instance, we could take 0 and discover indeed this comes out to minus 6. So we know that works. And if I put in 1 here, it comes out to 0. So we know that works. And if I put 2 here, it comes out to 0. So we know that works. And if I put minus 1 here, it all comes out to 0. So we know that works. We could even take a point way off here. I could say like, okay, what about minus 1? Or sorry, I've got minus 1. Minus 2. Minus 2 makes minus 1, minus 3, and minus 4. So that's minus 4 times minus 3 is plus 12 times minus 1 is minus 12 times minus 3 is plus 36. So that means right here, it's way down here. So now I know it goes way down and then comes up. So I can draw it even better now instead of drawing it like this. So you can always test it out. Make sure your graph meets that criteria. What about this one up top? This one we have to use a visual. I'm going to just take this and enlarge it. Well, I can see the 3 x-intercepts and I can see it's a cubic. So right away I can write it as a cubic. Got to put an a here because sometimes there's a number. And it's plus 2 for the leftmost, minus 2. And it's x minus 1 for the 1 comma 0. And it's x minus 3 for the 3 comma 0. And then you might say, well, we don't have another point. We've got several points, actually. We've got this point here, which is 0 comma minus 5. So that's the y-intercept, 0 comma minus 5. But I can see another point up here, 2 comma 4. So that should work. And I don't really see any other clear points. You always want to find a clear point. I mean, maybe technically there, but then we're dealing with big numbers. So let's work with simple numbers. 0 minus 5 is very easy, and so is 2 comma 4. So we know these are indeed the x-intercepts. We know it's a y graph, by the way, it's a negative. It's negative because it's starting up here instead of usually it starts down there. So we know this is going to end up negative. If it doesn't, we did something wrong. And we simply plug one of these numbers in. Let's plug -5 for y, because I know when x is 0, y is -5. That's what the y-intercept is. And then I just put in 0 for all my x values, because they're pretty much telling me that the y-intercept is that. And then I can just see from these brackets, this is what these become. +2 times -1 is -2. -2 times -6 is, oh, and I probably did something wrong here, because I can see that this is going to come out as, no, it's going to come out as negative. -2 times -3 is +6. And divide both sides by 6, and I get a is -5 divided by 6, which means I can go back and replace this in my general equation as this. Now, to test this out, if I really want to test it out, I know that when x is 2, I should get a 4. At least I hope so. So let's pretend I put a 2 in here and see what happens. Well, 2 plus 2 here is 4. 2 minus 1 here is 1. 2 minus 3 here is -1. -1 times 1. Yeah, I don't think this quite works. So 2 comma 4 is probably not a legit point. And I get -4. Maybe I did the other ones wrong. So I'll just do it again. 2 times -1 minus 2 plus 6 is equal to -5, right? Is that what I got here? Oh, that's not -5. That's -6. So the point here is 0 comma -6. So that means when this is -6, this is 2 times -1 times -3, which comes out as +6. And then -6, when I get -6 is equal to 6a. Divide both sides by 6, I get a is equal to -1. So a is -1. Good thing I checked. Now we can test it out with that other point that I think exists. So it's just a minus here, -1. Now we can test this other point. When x is 2, I should get a 4. Well, 2 plus 2 here is 4. 2 minus 1 here is 1. 2 minus 3 is -1. -1 times 1 times 4 is -4. -4 times -1 is 4. So indeed, when x is 2, y is 4. This equation produces this dot, and all 3 other dots. Therefore, it's the right equation. The equation is y is equal to -1 times x plus 2 times x minus 1 times x minus 3. And this -1 indeed makes it the beginning behavior and behavior like that.